Okay, this is this is part 6b. We're talking again about the truck and the car, but this time the question is about the direction of the velocity. So it goes like this. They're saying that the velocity of the car is 60 kilometers per hour, and obviously we can assume that that velocity is relative to the ground. Remember, when they say nothing about the velocity, we can assume that it's relative to the ground. So this one will be 60 kilometers per hour, and the other velocity, the velocity of the truck, is 20 meters per second, but in part A we converted that into kilometers per hour, so what we have is a velocity of 72 kilometers per hour. This is the velocity of the truck relative to the ground. Now the question in this part B is what is the velocity of the truck relative to the car. So if we go to the relative velocity equation, like the general equation we have, we're going to see that the velocity of the truck relative to the car will be velocity of the truck relative to the ground minus velocity of the car relative to the ground. I write truck first and car second because in this one truck goes first and car goes second. So now what I have to do is I have to do this operation here, but I have to use these vectors. So the operation that I'm going to do is velocity of the truck relative to the ground, which is this velocity, right? And then minus the velocity of the car relative to the ground. So I'm going to do this minus this, right? Well, I just need to do that operation with those two vectors. So obviously I have to draw because I cannot add values because they are vectors. So I'm going to do velocity of the train relative to the truck, sorry, relative to the ground, which goes like this. I'm doing this operation over here. So velocity of the truck relative to the ground minus this arrow. So I'm gonna draw, starting at this point, I'm gonna draw the arrow, but because it's negative, I'm gonna draw it in the opposite direction. So with this, I'm doing the blue one minus the red one, okay, this one minus this one, and the resultant value that I want is this, right? This arrow here will be velocity of the truck relative to the car. So I know that this velocity is 72 kilometers per hour. I know that this velocity over here is 60 kilometers per hour. So because this is a right triangle, the right angle is here, I can use Pythagoras theorem and say that the velocity of the truck relative to the ground, that is the hypotenuse of this triangle, will be equal to the square root of 72 squared plus 60 squared. And when you do the maths for that, you're gonna get that the velocity of the truck relative to the car will be 94 kilometers per hour. Okay, and that's the magnitude of the velocity. In the question they say that we have to find the magnitude and the direction of the velocity. So this is just the magnitude. We're still missing the velocity of the the direction. So to find the direction, I'm gonna draw the same triangle again. So it's more like clear for you. So we have 72 here, we have 60 here, and we have the total, or the velocity of the truck relative to the car. This is the same triangle, you can see. And to give the direction, which is what I'm missing, I'm gonna draw this north, south, east and west, right, to know what angle I have to find. So the direction of this vector over here is given by this angle. I'm going to call this angle alpha. So using trigonometry, something that you already know, using SOHCAHTOA, you can find that the tangent of the angle is opposite side, which is 60 over 72, which is the adjacent side. And then I do alpha, which is what I need to find. The angle itself would be equal to tangent minus 1 of 60 over 72. And I can do that in the calculator. Here it's very easy. You just have to press shift, tangent, and then in a parenthesis you write this 60 over 72, and then you get an angle of around 39.8 degrees, which I'm gonna round to 40 degrees. So now I have found the direction, right? I know that the magnitude of a vector, the magnitude of the velocity, is 94 kilometers per hour, and it has a direction of 40 degrees. But to complete the answer, I need to give like one complete sentence or one complete answer describing the velocity. So I'm going to say that the velocity of the truck relative to the car is 94 kilometers per hour, and I'm gonna say that the direction is 40 degrees south from east. So you can see that this is the east direction, and this angle is 40 degrees down. So the way we say that is 40 degrees south from east. So this will be your complete answer. If you just say 40 degrees and you say nothing else, it is not clear where those 40 degrees are. They could be here, here, and any place. So once you have found the angle, you have to specify where that angle is. So in this case, it's 40 degrees south from east, because you start from the east and you go down, that is, you go south. That is the whole process and answer for question 6b.